Hey fellow YouTubers, this is N0AGI. I'm here to do a short video. This might be a multi-part video series on these NIXIE tubes. I got them on eBay. These are the N0AGI model, and I'll show you a little bit detail on this shortly here. And then I got about 50 of these. They arrived on postal from Ukraine. So these are fairly cool NIXIE tubes. These are 12A. So the difference between 12A and 12B is the decimal point is disabled or not connected on the 12A version, and the 12B version has a decimal connectivity, so you could light up the dot if you were to build measurement sort of a circuit using these. These are the drivers. These are the switching BCD to decimal drivers specifically made for NIXIE tubes. These are able to carry high voltage switching capability. These are made in Russia also. I got 100 of these just to save some shipping costs, etc. But these are specifically made for operating and switching these NIXIE tubes based on 4-bit binary values. Okay, so I'm not going to go too deep into these today, at least not in this video, and I will have a video to go a little bit deeper. But for this section, I just want to cover something really quick. These NIXIE tubes operate at a very high voltage. They are designed to operate at about 170 to 180 volts DC. I've seen somebody operate these on AC voltage, but once you put AC through these, it gets all kind of blurry and weird looking. So the recommended voltage should be DC really for these. And given that these operate at a very high voltage, DC voltage of 170 volts, a regular 9-volt battery will not cut it. So you'll have to come up with a DC to DC boost circuit that will take an input of 12 volt as an example, and convert it to a 170 volts. There are several circuits available that you can build your own, and then you'll have to then tweak it, tune it, just to make sure it's putting out a consistent whatever set voltage as the output. Or you can go buy a prefabricated DC to DC boost circuits, as they're called, on eBay, and use them. So what I did was I went and bought these DC to DC circuit boosters, voltage boosters, and what they do is they take input from a standard 12 volt input, and then they convert that to whatever voltage you set it on the pot here. And I set it to 170 volts just to dry run these NIXIE tubes. One other thing to note about these NIXIE tubes is they are common anode. What that means is you connect there's one anode leg on these NIXIE tubes. Let me see if I can pull those out. Okay, so these legs here have, let me see if I can focus that. Maybe I'll set it up here. Okay, let's see if I can catch that. So each of these legs is responsible for one of the digits in the NIXIE tube. So there's a leg for 0, 1, 2, 3, 4, all the way up to 9. And then there is a leg here, or a pin here, to connect up to the anode, the positive of the DC. So if you look in the NIXIE tube over here, you see this white marked pin. That is the anode that serves as a common anode for the rest of the pins. So you connect this up to your positive 170 volts, and then you connect whichever leg to the ground. The corresponding digit would light up on the front of the NIXIE tube here. Okay. Again, I won't repeat a lot of the things that are already very well described on YouTube. The way these NIXIE tubes work, it's filled with neon gas, and each of the digits is layered or stacked on one top of each other, and as you light up each of the digits, the corresponding filament or the grid lights up and emits the light for the corresponding number or the digit. You'll see that shortly here. So I just want to make sure I at least covered that these NIXIE tubes have common anode, and the rest of the pins are grounded based on which digit it is that you are lighting up. Okay. And these pins here, they take the 4-bit binary number. It knows how to decode that number, and then the pins on the other side of the chip are hooked up to each of these digit pins, and when a binary number is sent to the 4 pins, the corresponding decimal value of that number, of that binary number, is lit up by doing a high current sourcing through the internal transistor. So the corresponding pin would, let's say for example, if the binary was right to left 1 0 0 0, that would be the number 1. That would then ground the number 1 pin, or the pin that's corresponding to the number 1 digit, to the ground, and the digit number 1 lights up. Okay, just a very high level. I'll go into this detail a little bit more again in my next video. For now, I just want to at least set the stage for where we are going. So the common anode for these NIXIE tubes needs 170 volts DC. Okay, so given that this is a high power DC to DC, high voltage rather, DC to DC circuit, be extremely careful when you use these circuit boards, or if you were to build one yourself, use extreme caution. And if you're not comfortable with high voltage or working with high voltage circuits, do not attempt to proceed with this experiment. Again, use at your own risk, and don't poke your fingers or your screwdrivers or any of that stuff, especially into this section here. They carry really high voltage when you turn them on, and that can, by touching those with your fingers or whatever conductor, metal, screwdrivers, etc., can grow cacti on your back. So not a good stuff. All right, so let me so what I've done here is I've hooked up the input. The red and the black go to the the 12 volt supply. I haven't connected the positive yet. And then this particular circuit board, the booster, comes with the third pin, which is the shutdown pin. For this to work, you just need to connect both the ground and the shutdown pin together and hook that up to the negative on your power source, your 12 volt power source. All right. The other end is the business end of the circuit, because this is where the high voltage is put out by the circuit board. So use extreme caution, like I said. Okay, so what I've done here, let me get my pointer. What I've done here is I hooked up my multimeter to the output of the boost circuit, and I'm going to power up the power supply, and that's putting out 12 volts, and the boost is putting out 158.7 volts, and you can adjust that voltage or the output voltage using the this pot here, like I was telling earlier. So you could I'm gonna see if I can get okay, let's see if I can get this closer, like so. And I'm gonna adjust the pot, and as I decrease, the output decreases obviously, and then you can increase it to whatever you prefer. I noticed that the NIXIE tube can actually work at 150 really well, and I think I'm gonna keep it at 150 for now, or somewhere in that range. So let me change that to 150. Oh, yeah, that's good. 150 point. Yeah, that's fine. 151.1 or whatever. That's fine. I'm gonna leave it there. So it's operating this circuit here. Let me not use my finger. This circuit here uses 12 volt input, and then up converts it to 151 in this case volts. But this circuit, this board can actually work at 9 volts input and still produce the required voltage, high voltage. Of course, when we do that, or if we do that, what happens is there'll be more current pulled because of lower voltage, right? Just Ohm's law. So anyway, so I'm going to leave it at 12 volts input and leave it at 151 volts output from this boost. And I'm gonna, what I've done here is I've taken one of the NIXIE tubes, and I hooked up the yellow lead here to the common anode, which is right about here, and then hooked up the white lead to one of the digits up on the top here. Okay, so let me see if I can get you a better view. So basically nothing fancy, very straightforward. Alright, so what I've done here is in the back I connected up the yellow lead to that common anode leg of the NIXIE tube. Alright, so what I'm going to do now is I'm going to basically couple these up to the output of the boost board, and we'll take a look at it. I'll be right back. Okay, so this is what I've done. I basically coupled the NIXIE leads to the multimeter leads and the business end of the boost circuit board. So let me power up, and so it's producing 151.8 volts. And that's our NIXIE tube. We are seeing digit number 7. You can tell that it's not the brightest of the NIXIE illumination, right? So I've seen, let me turn on my the 5245L counter. This is one of those 1970s mil-spec counters I got on eBay a few weeks ago. Absolutely cherish this unit. Still functions like a charm. Alright, so anyways, so that's the brightness of those NIXIE tubes. And I believe they're the same IN0AGIs, or yeah, 12As. I think, I could be wrong. But anyways, if you look at this one here, it's not that bright. That's because our voltage is at 151. They recommend changing that to, let me increase that, and you can tell this is much brighter. There you go. That's much better. In fact, if I changed this to, it's at 168.5 or somewhere there, and I can see this is much brighter than the one before. So I guess you get the drift. So there is a good opportunity for us to mess with the output voltage to increase or decrease the brightness of your NIXIE. I've seen folks running this at a much lower, or let me actually increase this to 170, which is a recommended input voltage for these NIXIE tubes. Let's see. So that's running at 170 now, 171 or there, somewhere thereof. That looks pretty good. Now I've seen in some cases where if it goes up to 170, you start seeing some neon burn, a blue-colored neon burn at the base of it. I don't know if that's an issue with the NIXIE tube or what, but anyways, I'm gonna plan for 170 or somewhere in between 165 170 in my next steps here. So anyways, I thought I'd give you a quick view of this first dry run of this project. What I'm planning on doing is a NIXIE tube tester, as well as building a microcontroller based one NIXIE tube clock. So that could be my project number 2, but for now I want to build a NIXIE tube tester circuit and see how that shakes. Thanks for watching, and really do appreciate that, and look forward to connecting back with you all. And if you like this video, please give me a thumbs up. Thanks for watching. We'll talk soon. Bye.